era of dy by dx is over. So what is dy by dx or dfxy dx? So we are calculating uh, the change in dependent variable as per the change in the independent variable. So rate of change, that what we call for the differentiation. So there, uh, per unit change in the independent variable, that is x, brings how much change in the dependent variable, that is fx. Okay, so repeatedly I am saying that era is over in the sense that variation in the dependent variable, that is y or fx, as per the unit variation uh, in x, that we have been calculating. Now the scenario is that this is nothing but variation of y along I vector. Dy by dx is variation of y or variation of fx function over x along I vector. What about function a variation of fx along any vector u? So this is the new scenario. So dy by dx era is over. Now it is dy by du. So dfx by du, variation in dependent variable fx function over x or y as per the unit variation in along the vector u. If that is the scenario, then it leads to multivariate in a sense that dfxy by du, dfxyz by du, or dfxyz alpha beta gamma up to n by du. So, as per the how many dimension it is. So, one dimension, two dimension, three dimension. Now, if that is the scenario, then through chain rule, we saw that dfxy by du equal to d. Okay, so dfxy by du equal to dfxy along the x-axis, along the I vector by du, plus dfxy along jx vector by du. So dfx by du equal to dfx by dx into dx by du plus dfxy by dy into dy by du. If that is the case, then we came to a conclusion that there are two vectors that are coming into the picture. So dfx by du equal to gradient vector dot u vector. So gradient vector is gradient vectors x component is dfx by dx, y component is dfxy by dx, and y component is dfxy by dy. Whereas the u vectors x component is dx by du and y component is dy by du. So dfx by du equal to gradient vector dot u vector. Dfx by du equal to dfxy by dx into dx by du plus dfxy by dy into dy by du. So dx by du and dy by du are two components of vector u along x-axis and y-axis. We can take unit vectors and gradient vectors also will take as a unit vector. Now the other vector is, this is u vector, other vector is gradient vector, that is dfx by dx and dfxy by dy. These are the two components, so it is also called partial derivative. Now question comes is, what is the direction of gradient vector? So this question arises, what is the direction of gradient vector? So we started discussion with y equal to x square. If y equal to x square, then we can have x square minus y equal to 0 or x square minus y equal to k. So we have a kind of multivariate function and fxy equal to x square minus y. If that is the case, then dy by dx, that is the kind of rate of change in y along, now I won't say rate of change in y with respect to x, rate of change of y along I vector dy by dx is kind of 2x square. So if I say y equal to x square, that was the initial equation. If y equal to x square, then dy by dx equal to 2x. Okay. So later we'll come to multivariate function. So y equal to x square, then dy by dx equal to 2x. If that is true, then the rate of change or the gradient line or the tangent line that we draw. So if I have y equal to x square, function is like curve. Okay, x square will start, okay, little linearly, and suddenly it will go up. So at any point, what is the tangent? The equation of the tangent line is y equal to mx. Okay, means the equation of the tangent vector, rather I would say. So y equal to mx means y equal to 2ax, where 2a is the kind of a slope at any point a. So dy by dx was 2x. If y equal to x square, dy by dx is 2x. Then y equal to 2ax is the equation of the tangential line. This proves that y, if for each increment in x, okay, so y varies 2a times than x. Y varies 2a times than x. If that is true, then equation of vector is I plus 2aj. Okay, so I plus 2aj, because in j direction it is 2a times more than that. So vector equation of the tangential line is I plus 2aj. Now if I see the multivariate function, then x square minus y equal to k. Y equal to x square means x square minus y equal to k. So fxy is y square minus x. So now if I calculate the gradient vector, so gradient vector x component, that is partial derivative along x axis dfxy by dx is 2x, whereas dfxy by dy is minus 1. If that is true, then gradient vector is 2ai minus j. So gradient vector is 2ai minus j, where a tangential line is I plus 2aj. Now we have calculated dfx by du, the rate of change in the dependent variable, that is dfxy multivariate dependent variable. Independent variables are x and y. Dfxy by du along the vector u, what we calculated, that is variation in the dependent variable function over x and y along u vector. If u vector is tangent line dfx by dfxy by dt, your tangent line is I plus 2aj. Okay, so dfxy by dt along the tangent line, if that we calculate, then it will come as gradient vector dot u vector. So gradient vector is 2a minus j, and u vector, that is a tangential line, that is 2i plus 2aj. One is 2a I minus j gradient vector, another is I plus 2aj. If I do dot product, then their x and y component would get multiplied and then added. Say so 2a minus 2a, so 0. So this proves that the tangential line, the gradient vector is perpendicular to the tangential line. 2D. What about 3D? So that question arises. So gradient vector dot grad the dfxy along the tangential line, that is gradient vector dot tangential line, okay, in xy plane, if we calculate, then it comes as 0. So in xy plane I have equation like y equal to x square, then the tangential line what we draw and the gradient vector both are perpendicular to each other. Okay, now we'll see 3D. So if we have 3D, then we have kind of instead of tangential line, we have tangential surface. Okay, and gradient vector would be 3D. So instead of only dfxy dx, so now it will come as dfxyz by dx, dfxyz by dy, and dfxyz by dz. So there would be a three component in the gradient vector. Okay, so if there are three component in gradient vector, then what is the tangential line equation? So tangential line equation should be perpendicular to the gradient vector. This is what we have calculated. Okay, now if we see the local linearity, I mean I have a sphere. This is summertime, so in summertime we have so many fruits here. So uh, okay, so this is melon. Okay, so I would consider this as a sphere. Okay, so at any point, if I want tangential surface, then like at any point, tangential surface will be like this. Okay, so top it is flat, whereas tangential surface at any point would be like this. These are the tangential surface at any point. Okay, and if I want to calculate the gradient vector, okay, so gradient vector would be if I have a tangential surface like this at any point. So if this is tangential surface, then gradient vector. So if this is the tangent, if it is tangent, then gradient vector would be perpendicular to this. If it is a tangential surface, then gradient vector would be perpendicular to this. If it is a tangential surface, then gradient vector would be perpendicular to this. Okay, if this is tangential surface, then gradient vector would be perpendicular to this. So this is what we are seeing. So what is the equation of tangential surface? That comes in the question. So tangential surface means that like if I have a sphere and if I see from far, it looks like a sphere. But if I go near to this near, I'm seeing now almost flat surface. Okay. So if I go exactly at a point where I'm looking very near, okay, tends to zero, I'll exactly see a flat surface. That is the tangential surface. What is the equation of tangential surface? That comes into the picture. So equation of tangential line in single dimension is y equal to mx. Y equal to where m is the dy by dx at that point. So gradient at that point. So y equal to mx. In 3D, it will come as more or less as dfxyz by dx x minus x0 plus dfxy by dy y minus y0 d plus dfxyz by dz z minus z0 equal to 0. So this is the equation of or any constant. This is equation of the tangential surface. I would make it simple. So it would be something like fxy, fxy. If I talk about two coordinate, fxy equal to m1x plus m2y, y equal to mx single dimension, fxy means z equal to y equal to mx, then z equal to m1x plus m2y, where m1 is dfx by dx, m2 is dfxy by dy. So if I take if I take partial derivative along x-axis, partial derivative along y-axis, then z equal to dfxy by dx into x plus dfxy by dy into y. So it is not very difficult to kind of think about it, to kind of do some interpolation. So if I have I keep talking about it. If I have a surface like this, then like kind of what is z? Then what is the z equal to dfx by dx into x plus dfx by dy into y. So whatever the slope we see, dfx by x, dfxy by x. slope along x-axis plus slope along y-axis. So if slope along x-axis is also positive and slope along y-axis is also positive, then z will be get added twice. Otherwise, there is addition and subtraction. So what is delta z? If z equal to fx x x y into x plus fy x y partial derivative along x axis and y axis. So d fx x x y x plus fy x y y, that is z. Then for delta x variation along x axis and delta y variation along y axis brings how much variation along z axis. So delta z equal to fx x x y delta x plus fy x y delta y. So these are the equation in the variation. But as far as the surface equation is concerned, that comes as z equal to fx x x y fx x y x plus fy x y y. Now, if I talk about 3D surface equation, then z will bring it to that side of the equal to, and complete equation will be that fx x y z x plus fy x y z y plus fz x y z z, where fx x y is dfx y z by dx, fy x y z is dfx y z by dy, and fz x y z is dfx y z by dz. So these are three the partial derivative along their axes. Now, if I have a point through which it is passing, that is x0, y0, z0. So earlier equation is fx xyz x plus fy xyz y plus fz xyz z. Now, if it is passing the surface, the 3D, the surface equation what we have kind of brought in, if it passes through a point x0, y0, z0, then it will come as fx xyz x minus x0 plus fy xyz y minus y0 plus fz xyz z minus z0 equal to 0 or constant. So this is the equation of tangential surface at any point x0, y0, z0, or fx y fx xyz x minus a fy xy xyz y minus b fz xyz z minus c. So this is a tangential equation of a surface where tangential equation of a surface where it passes through at point, rather at point a b c. Earlier it was x0 y0 z0. Now we have a tangential. We have gradient vector. Gradient vector is nothing but dfxyz by dx, dfxyz by dy, and dfxyz by dz. These are the three components of the tangential of the gradient vector. Whereas the equation of surface, I'm not talking about vector, equation of the tangential surface. Okay, so if this is a sphere at any point, the equation of the at any point the equation of the tangent. So any point is the point that is touching the sphere. This is ABC. If it is touching here, that is ABC. If it is touching on top, then this is ABC. Okay. Now, if it is touching here, that is ABC. Then at ABC, if this is tangential surface, then this perpendicular tangential surface is the gradient vector. Now we have equation of gradient vector, that is dfxyx, dfxyz by dx, dfxyz by dy, and dfxyz by dz. If these are the three components of gradient vector, and we have equation of the tangential surface as dfxy by dx into x minus a plus dfxyz by dy y minus b plus dfxyz by dz z minus c equal to k or constant. Then what is the equation of tangential line? I'm not talking about tangential surface. So now question arises is that if this is the tangential, if this is the tangential, if this is the tangential surface, and this is the gradient vector, then tangential line would be perpendicular to the, so if this is the gradient vector that is perpendicular to the tangential, so any along the tangential surface, okay, so if I'm talking about tangential line, if this is tangential surface and this is gradient vector that is perpendicular to the tangential surface, the tangential vector would be anything along the surface that is touching the point A and B. If this is point A and B, along this surface, any line that is floating on this surface is the tangential line, because it is confirming that it is perpendicular to the gradient vector. If anything that is perpendicular to the gradient vector and it is falling on the tangential surface is the tangential vector. Then what is the equation of tangential vector? What is exactly the tangential vector? That comes to the question. Okay, so if this is the if this is the sphere and this is the tangential surface, then along tangential surface the tangential vector would be anything. Which is the exact tangential vector? Because if this is tangential vector surface, then this is the gradient vector. So this is perpendicular. Anywhere it is perpendicular to the gradient vector. But which is the actual tangential vector? That comes to as question. Now, suppose that suppose that this is suppose that this is tangential vector. Sorry, this is gradient vector. If this is gradient vector, then this is gradient vector, then this is the height. This is z component. Now in the xy axis, we have x component and y component. X component and y component comes as a line in xy plane. Now, if I give a height of z, then it becomes a gradient vector. What is perpendicular to the gradient vector? Can I keep xy same? If I keep xy same, then only thing that I need to change is z value. If that is the true, then direction. So this direction, what we are saying, only it will vary along the z axis. If that is true, then along x, if I say that I have a new line, new surface, that is xy surface. This is x, this is y, and resultant vector is this angular, then this is xy vector surface. Along this vector surface, this is gradient vector. If I move somewhere so that it will become perpendicular to the gradient vector in the same line, then this will become tangential vector. So if I keep x, y value same and only vary z, in a sense if it is x-axis, this is y-axis, and this is the resultant vector that is on the xy plane where we have x value and y value. Now in this xy plane, if I, okay, so x y z, now if I move, this is x y z plane. In this plane, if I move somewhere, then it becomes a gradient vector. If I move 90 degree in the same plane, then somewhere it will become the tangential vector, either this or from here 90 degree like this. This is the gradient vector, 90 degree like this in the same xy value. So this is tangential line. Okay, very precious. I mean, much more precious than billions of dollars. So, mathematics, you are amazing, you are awesome, you are priceless. Means there is no price for mathematics. It is awesome. Okay. So, the most kind of priceless thing that is gifted to a human. So, if we have if we have a gradient vector like this and we want a tangential vector on the tangential surface, then since this is perpendicular, if this is tangential surface, this is perpendicular to the tangential surface. Along the tangential surface, we want tangential vector. If that is the case, then better we'll keep this gradient vector xy constant, only z will vary. If you vary z along this xy plane, xyz plane, then somewhere we'll hit the tangential surface. Okay, so if this is tangential surface and this is gradient vector, and here is our sphere, here is our watermelon, and this is tangential surface, and this is gradient vector, then gradient vector has x component, gradient vector has y component, and gradient vector has z component. X and y, if we keep constant and keep moving z, after 90-degree it will hit gradient, it will hit tangential surface, and that vector is a tangent vector. But anywhere in the tangent surface, it is 90-degree to the gradient. So it satisfies. But that way we'll find the we'll find the tangent vector. So if we have a gradient vector as ai plus bj plus ck, or alpha I plus beta j plus gamma k, if this is the gradient vector, then alpha I plus beta j plus any mk. So alpha I plus beta j plus gamma k is the gradient vector. Then alpha I plus beta j plus any mk is the tangential vector. Now if I do dot of these two, then it will become 0. So alpha square plus beta square plus gamma into m equal to 0. We can get the m. Now we get the tangential vector. This is amazing. Tangential vector, if I have a sphere and if I know the tangential vector, then can we see this? This sphere is, this is tangential vector. This can also be a tangential vector. This can also be a tangential, because all are in tangential surface. But the actual tangential vector would rise fastest along the contour. So if this is the contour, then if here we are at some height on a hill and this is at some height, then this direction of the tangential vector would go along the fastest change in the contour line. Means the tangential vector rise fastest in the contour line. So gradient vector also. Only thing is their angle is 90 degrees. So gradient vector also go in a direction that is fastest along the contour, but it is 90-degree to the surface. Okay, so gradient vector is 90-degree to the surface, but here gradient vector, here gradient vector, here gradient vector, here gradient vector would shift along the, if it is too heavy, I believe more than 2 kilograms, 3 kilograms. So if this is gradient vector, then gradient vector would move, okay, in the fastest slope that we see along the contour. Contour means cross section in the z direction. Now if we see the tangential vector, then it will exactly grow and the fastest rate. So tangential vector gives the direction any point that how fast we can climb on the mountain. So from the gradient vector, we calculate the gradient vector is the beginning. From there, we calculate the tangential surface, and then gradient vectors 90-degree. We keeping xy constant, we calculate the tangential vector. So if we do dot product of tangential surface and tangential vector, any line on the tangential surface tangential vector, then it would be kind of it should be whatever we see dot product of the 0 degree. So it will be on the same surface. Now direction of tangential vector is sharpest rise at that point along the z-axis contour. Okay, so this is kind of story of gradient vector. Okay, so this is the story of gradient vector, calculating the gradient vector, and then calculating the tangential vector. So they go in the gradient vector is perpendicular to the surface, whereas tangential vector would rocket. So it will rise fastest along the fastest chain in the contour. So this is chain rule story. Through chain rule, this big story that would be described in probably 40, 50 pages in mathematics book, we, with the chain rule, so nicely, so easily, we finished it. So go to the hill and calculate tangential vector and finish in minimum time climbing up to the peak of your career.